establishing is Le Chartier's principle, okay? So we can talk about changes in pressure and changes of amounts and the Chartier's principle. I hope that's more or less a review for you. I'm not going to talk about this any because I don't want to take up too much more time. So review your basics on the Chartier's principle if you need to, okay? But really what I was getting into there is the changes in temperature with Le Chatelier's principle, okay? And so again, what we establish here is the necessity, the dependence of temperature on these spontaneous reactions, okay? And so, for example, if I have an exothermic reaction, as indicated right here, if I increase the temperature, it's like I'm adding more products, right? And that's going to make the reaction favor the reactants, right? Okay, so that's why if I decrease the temperature, if I have a low temperature in an exothermic reaction, we know that it's going to favor products, okay? So, and similarly, in an endothermic reaction, we know energy is a required reactant. So this is where if I have a high temperature, if I increase the temperature, I can actually drive this reaction to products, okay? Even though it might be endothermic, I can still make it proceed spontaneously if I drive up the temperature high enough, and that makes good sense. And of course, similarly, if I decrease T on an endothermic reaction, then I'm going to be, pushing my equilibrium to the reactants, okay? And so all of this is established, so we can then recognize that the only thing that actually changes the equilibrium constant is temperature through this equation. K equals the exponential of negative delta G of reaction divided by RT. So we recognize that K is dependent upon what the temperature is. So with changes in pressure or changes in amounts or changes in volumes, I'm not going to go through this, but it does not change the equilibrium constant. Does not change K. But we do know that changing amounts, which is more or less the same as changing pressure or changing volume, can shift equilibrium to reactants or products, okay? And if you had me in Chem 110, we spent a glorious, hideous amount of time discussing all of this stuff, okay? So that's really all I want to say about equilibrium. I actually want to say a lot more, but I'm trying to get us to come back, get back in time with the course. So hopefully this was a little bit new for you. Hopefully you learned a few things about equilibrium that you didn't know before. That's kind of my main goal here. You talk about equilibrium in every damn chemistry class. So hopefully I was able to hit on some things that were new for you. Okay, folks, so this wraps up thermo. We're done with thermo. Yes.